All right, section 4.6. We're still talking about triangles. This whole entire chapter is about triangles. We're getting away from the proofs and the side angle side stuff, but we are going to be talking about some triangles that we have dealt with before. And here's, actually, that's not the triangle I want. Let's see, I think it's this one right here. Yep, that's the one I want. All right, so let's make this a little bit bigger so we can work with it. And I'm going to stretch it out a little bit like that. Okay. It was an equilateral triangle. It was an equilateral triangle, and now it's an isosceles triangle. So what I want to do is I want to talk about an isosceles triangle. We've discussed an isosceles triangle before, but let's get into it just a little bit more. This side and this side would be equal to each other if this is an isosceles triangle. And let's label it ABC. And let's talk about some of these names. We call the two equal sides of an isosceles triangle. Actually, let's write isosceles down. And I've spelled this for you several occasions, kind of give you a hint. We split it into two words, isos, I-S-O-S, and then celes, C-E-L-E-S. All right? Even after I said that before, I'm getting some crazy, whacked out spellings for this, okay? Just look at it for a minute, all right, and spell it right, isosceles. So it's an isosceles triangle, which means at least two of the sides are equal to each other. The two sides that are equal to each other we call the legs of that isosceles triangle. So that's a leg and that's a leg. All right, we'll get rid of that S. So that's a leg of the triangle, and that's a leg of the triangle. Now, the side that's not equal is called the base of the triangle. All right, so these are good words because sometimes you got to learn vocabulary, and in geometry you've noticed that we learn a lot of vocabulary before we learn something new. All right, because we got to refer to these things. So that's a leg, and a base. You also talk about these angles right here. They talk about this angle right here is called the base angle, because it's the angle that's formed with the base. Everybody see that? So that's a base angle. What do you think we could also call this angle right here? It's an angle that's formed with the base as well, isn't it? So we'd also call this a base angle. Would we call this a base angle right here? No, because it connects the two equal sides, okay? And I think I know what they're going to call it. Yep. They call this right here a vertex angle. Vertex angle. All right, so we've got the legs, the base angles, and the vertex angle. So that's just a little bit of vocab right now. And let me copy and paste this one more time. And let's talk some math on this. Okay, what things are equal to each other? Again, it's isosceles, and we have a theorem. Yep, it's a theorem. It's called the Isosceles Triangle Theorem. Let's write that down. Isosceles. Here's another chance to spell the word isosceles. Spell it right. Isosceles Triangle Theorem. All right. Theorem's kind of weird. It's E-O-R-E-M. Theorem. All right. Isosceles Triangle Theorem. Yes. What's that? No, you can put symbol. I've been doing that for a long time now, okay? You don't have to put the word triangle, just put the symbol for triangle. So this is called the Isosceles Triangle Theorem. This is what it says. If you have two sides of a triangle that's equal to each other, which means it's isosceles, right? Now listen to this. It says that the angles opposite those two equal sides are also going to be equal to each other. All right? The base angles, right? The base angles will also be equal to each other. So the angles that are opposite the equal sides are also going to be equal to each other. All right, and that's pretty nice thing to know. For instance, if I knew that this was 30 degrees and that's all I knew, but I knew it was an isosceles triangle, I could actually find all the angles of this triangle. Just knowing that one angle, I could find the other two angles by knowing that it's an isosceles triangle. So what's the easiest angle to find? If this was 30, we'll go ABC again. So if angle B is 30, tell me something else. Angle C is 30 as well, isn't it? Everybody see that? Because it's an isosceles triangle, and the base angles of an isosceles triangle are equal to each other. Okay, the angles that are opposite those two equal sides are going to be equal to each other. We could also find that third angle. This is something that we've learned before. It's nothing new. That we could find that third angle right now. So what's that third angle going to be? How do we do that? Remember, you got three angles. What do all three angles add up to be? 180. So how do I find this missing angle up here?
180 minus 30 minus 30.
Yeah. Or we can just go 30 plus 30 is what? 60. So we can just go 180 minus 60 is what? Is 120. So that angle right there would be 120 degrees. Everybody with me on that? All right. So they could do that. They very well could just give you one angle and ask for the other angles. What if they said that this side was 3? what would be the length of AC? It'd be 3 as well, because it's an isosceles triangle. This side is equal to this side. Okay? Now, you kind of know what they're going to do, don't you? They're going to make this like x plus 2, and they're going to make this like 3x minus 1 or something, right? Then you might have to solve for x. So what would you do if you had a situation like this? You'd set them equal to each other, wouldn't you? And then you could solve for x, right? They've been doing that all year, haven't they? Yeah. It's just different stuff. I don't think geometry gets harder and harder and harder. I really don't. I think once you learn the basics of it, about the first chapter, 2 or 3, something like that, after that, it just is different stuff. You're really doing the same math the whole year. The math doesn't really get much more difficult. You're just doing it with different pictures, different figures, different shapes. All right? And I don't think it really gets harder and harder. I think it kind of stays the same. Now watch, here's another thing that's true. That's called the Isosceles Triangle Theorem. It says, I'll just shorten this. If two sides are equal, then what? The two opposite angles are equal. Just shorten it really to make it real easy to see. So if two of the sides are equal, then the two opposite angles are equal. So here's the if part, that the two sides, I should put equal, sorry. If two sides are equal, then the two opposite angles are equal. Now watch this theorem. Tell you what, we'll just make this a little bit different. Still isosceles, but I just squeezed it in a little bit just to make it look a little different. Watch this. What if I was given, we'll call this DEF. Let's make that 2 point. What if I told you that angle E was equal to angle F? Now you remember, if the two sides are equal, the two opposite angles are equal. What do you think might be true if these two angles are equal? Then the two opposite sides would be equal, wouldn't they? Wouldn't you think? And that's absolutely true. They call that the converse of the Isosceles Triangle Theorem. Isosceles Triangle Theorem. I'll shorthand theorem, just put THM. Okay, this is the converse of it. What does that say? It says if two angles are equal, then, what do you think? The two opposite, what? Sides would be equal. All right, that's what the converse of it says. We changed the if and the then around, didn't we? Instead of saying if the two opposite, I'm sorry, instead of saying if the two sides are equal, then the angles are equal, we changed it around and said if the two angles are equal, then the two opposite sides are equal. You see that? We just did a switch with the if and the then. That's what the converse does. It switches the if and the then. So watch what I could say. If it was given that E and F were equal, I could look at this triangle and automatically say, so let's say that side was 5 right there. And I said, solve for that. If these two angles are equal to each other, I know that the opposite sides are going to be equal to each other as well. All right? Wow, that whole row.
You should take a picture.
I should. You know what I should do is give you SLD. Did that wake you up? SLD? Is that the magic word that wakes you up? Nah, man. Okay. Not exactly the most respectful way to address your teacher, but, you know, just saying. All right, here we go. So those would be true. Now, again, you could do the same thing. They could say, you know, they could put this in terms of x, and you'd have to solve for x or, you know, that kind of thing. So if the two angles are equal, the two opposite sides are equal. If they give you the two opposite sides equal, that means the two opposite angles are equal. All right? Let's see what I want to do here. Now, skip that. Let's do this. Let me go up and grab another triangle here. Grab that first triangle I was going to deal with. That one. All right. Now you can have a seat. Look at this triangle. This is not just an isosceles triangle. What do you think? It's equilateral. What? Here's an equilateral triangle. Now watch this. This is kind of interesting. Watch this. We're going to use what we learned before. If these two sides are equal, tell me, we'll call this XYZ. Tell me something about x, y, and z. Well, not necessarily all three of them, but about y and z. Y and z would be equal, right? So y and z would be equal. All right, that's pretty easy, but watch this. All three of these sides are equal, aren't they? So you could look at it this way. Look at these two. These two right here are equal to each other, so the angles opposite these two sides have to equal, don't they? So that means, look, that this angle x is opposite this side, angle z is opposite this side, so x and z have to be equal to each other as well. So if this has one arc on it, what do you think I'm going to put on x? Just one arc because they're equal to each other. So what's true about all three angles? All three angles are equal to each other. Okay, so, and we've talked about this before, but this is the first time where we actually had the theorem that actually showed that this is true. So we said that it was equilateral, didn't we? We were given that it was equilateral. We were given that all three sides are equal. And then we looked at it, and we talked about that isosceles triangle theorem. We said, hey, if that works, then all three of these angles are equal to each other. So an equilateral triangle is also a what? Equiangular triangle. All right, so anytime it's an equilateral triangle, anytime all three angles are equal to each other, anytime all three sides are equal to each other, that means that all three angles are going to equal each other. And it actually goes both ways, doesn't it? It goes this way and it goes this way. That's supposed to be a little arrow. So what if I told you that all three angles were equal? What could you tell me about the sides? All three sides are equal. So if it's equiangular, it's equilateral. If it's equilateral, it's equiangular. It goes both ways. That's why I put arrows on both of these. All right, that's kind of interesting. But I think this is even more interesting. Watch this. I didn't tell you what any of those angles were equal to, did I? But with this information, you could tell me what they actually do equal. I didn't tell you what this was equal. I didn't say this was like 40 degrees or 50 degrees or anything like that. I didn't tell you any information except that it was equilateral. Why do you say 60? Was that just a... That's right, because look, what do all three of these add up to be? 180, right? Do you agree with that? They're all exactly the same. So how could I find out each individual one? If I had $180 and I want to split it equally with three of you in here, what would I do? What math would I do? Is that what I mean? So I would do what? I divide it by 3, right? Okay, just divide it by 3. So what's 180 divided by 3? It's 60. So what are each of these angles in here? It's 60 degrees. 60, 60, and 60. Make sense? All right. So anytime, it doesn't matter how big or small your equilateral triangle is. Watch this. I could have a tiny little equilateral triangle right here. All three sides are equal to each other. What are all three angles then? 60 degrees. It doesn't matter how big or small, those angles are going to be exactly the same. If you don't believe me, watch this. I'm going to take this triangle, pick it up, and put it right here. Look at that angle. It's exactly the same, isn't it? Now, of course, the lengths of the sides are different, but the angle is exactly the same. This angle right here is exactly the same. And you get the idea, don't you? Okay? So that's kind of interesting, don't you think? All right, that if it's equilateral, I know that all three angles are going to be 60 degrees. Now, let me, if I could speak, give you a little example, and then give you the worksheet, and then you'll be good to go. Let's stretch this out just a little bit. We won't make it equilateral. So here's the kind of stuff they're going to ask you to do. Watch. Let's make this bigger, make this a different color. Let's say this angle right here is 80 degrees. Let's say this angle here is 6x plus 8 degrees. That's that angle right there. This side is 2x plus 2, and this side is 4y minus 2. And they also tell you that this side is equal to this side. That's the information that they give you. And you need to solve for x and you need to solve for y. What do you think we're going to do? Well, if I set these equal to each other, it's a little problem though, isn't it? Because I got an x and a y in one equation, so I wouldn't be able to solve for either one of them. So I can't just set these equal to each other. That's why they give you some stuff with the angles. Devin, what do you think? Summer, go ahead. Okay, you could find this angle right here, couldn't you? But you wouldn't go 180 minus 80 though. But you do need to know something about this angle. Remember, these two sides are equal, so what's true about these two angles? These two angles are equal, so what would I call that one? 6x plus 8, right? Now, what did I say? I've said this once before already today. What do all three of these angles do? they add up. They don't just equal. Let's not say they equal 180. I know what you're thinking, but they add up to 180. So guess what I'm going to do? I'm going to go 6x plus 8 plus what? Another 6x plus 8, okay, plus a what? 80, and what does all that equal? Equals 180. Everybody see that? And now you can just do the math. We're running out of time, but you could do the math and then solve for x. Once you solve for x, you could find this side right here, couldn't you? Okay? Once you find this side, that'll actually be a number, a regular number. Then what could you do to solve for y? Set them equal to each other. Everybody see that? So we solve for x, we plug it into this, and then we set this equal to whatever that number is. Then you get x and you get y. All right? It takes a little bit of thought, a little bit of imagination. But the math is no different than what we've been doing all year, is it? Not at all. Let me give you a worksheet. And now, you're going to do front and back, but there are a couple proofs on there, and you don't have to do the proofs. Do all the other stuff, but you don't have to do the 2 proofs. Okay?